AI feels like pure software. You can have an idea in the shower, write the code, and ship a new product 2 weeks later. But the foundation of this technology doesn't run on code. It runs on heavy industrial infrastructure. To power these systems, we need massive industrial turbines and data centers that take years, not weeks, to build. We are still in the early innings. Right now, AI mostly augments and automates what already exists. The applications that create entirely new industries haven't arrived yet, much like Uber and DoorDash only appeared years after the first iPhone. Enabling that next generation of applications is physically impossible with our current hardware. The primary bottleneck restricting the AI revolution is now built of concrete and copper. If we zoom out to the global macro level, the absolute limit on AI growth is electricity. Comparing annual power capacity additions, the gap is stark. The US adds 40 gigawatts, while China adds 550. Overlaid with a fulfillment timeline, we see massive lag. Data centers take 3 years to build, and turbine orders are backlogged to 2030. Even when that power is secured, a massive percentage of the electricity arriving at a facility never reaches the processors. Huge amounts of energy are lost in transmission, and managing the extreme heat generated by these systems is currently capping their performance. Before a single algorithmic calculation can occur, securing and cooling a multi-gigawatt power supply is the literal gate every AI ambition must pass through. When we step inside the data center, a new physical challenge emerges. We have to make 100,000 distinct processors behave like a single cohesive unit. Traditionally, these connections rely on copper wiring, but copper has hit a physical limit. It creates data traffic jams that choke the entire network. The industry is moving toward co-packaged optics, which means moving data using photons instead of electrons. It's difficult to deploy and maintain, which is why there is such a massive opening for anyone who can get it right. Upgrading a data center network after it's built is as painful and disruptive as tearing up an active highway. The company that successfully nails the deployment of these optical connections will capture the biggest financial shift in the industry. Zooming down to the surface of the silicon wafer, we find a counterintuitive truth. Processing the actual math is no longer the most expensive part of AI. The real cost is physically moving the bits to the processor. This new microchip architecture stacks memory and processing vertically into a 3D block, drastically reducing the physical distance data travels. This hardware shift matches a market shift. Historically used to train models, 80% of deployed silicon will soon run inference, operating models continuously. This shift changes general-purpose compute economics. For hyperscalers, highly specialized, workload-specific hardware is becoming table stakes to manage massive inference loads efficiently. At this microscopic scale, efficiency is no longer about building a faster general chip. It requires physically redesigning the data path for specific tasks. Back at the human scale, this technology is changing how we manufacture it. Today, one technician monitors 20 pieces of equipment from a dashboard. Organizations are restructuring too. Companies are building smaller, AI-native teams led by the AI captain, whose sole job is to remove administrative friction so autonomous teams can move as fast as the software. The largest tech companies are spending hundreds of billions of dollars on physical infrastructure, and they are openly admitting they cannot solve these multi-year hardware problems alone. This creates a massive opportunity. The gold rush shifted from flashy models toward the unglamorous picks and shovels: power, cooling, memory, and networking. The applications that will create entire new industries are still ahead, but realizing those applications requires us to abandon software timelines and start building for the heavy, slow, multi-year reality of the physical world.